Okay, we're on number 7, fifth degree polynomial. Let's go through the analysis, all right, at the whiteboard. So let's write the polynomial down first, f of x. Again, we're analyzing roots. Is going to be 2x5 plus 29 x4 plus 119 x3 plus 159 x squared plus 7x minus 60. And let's put the signs of the coefficients down. So plus, 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 minus. Let's make sure I count it right. 1, 2, 3, 4, 5, 6. 1, 2, 3. Yep. There's only one sign change. All right? So S equals 1. So what does that mean? That means S minus P, which is 1 minus P, must be a non-negative even integer. Well, the only way that could happen is if P is 0, P is 1. What does this mean? I have one positive real root. That's a given. Before I go forward, I want to point out this polynomial is going to graph like this. It's got a coefficient. On the fifth degree term, the leading term to be positive, so it's going to look that nature. It's what happens in the middle, I don't know. That's where the roots are occurring. All right, so I know there's one positive real root, and now what I need to do is I need to rotate the curve. All right, so when you rotate the curve, I'm taking the negative roots and making them positive. And I'm rotating it about the y-axis. So what do you get? Minus 2x5 plus 29 x4 minus 119 x cubed plus 159 x squared minus 7x minus 60. Let's write this down. Negative, positive, negative, positive, negative, negative. All right, I get dizzy sometimes counting here, but what do we get? There's one change here, one change here, one change here, one change here. So S is 4. All right, what do we get? S minus P, that's 4 minus P equals, well, it's going to be a non-negative even integer. So what could P be? P could be 0. That would give you 4. Can it be 1? No. Can it be 2? Yes. Because 4 minus 2 is an even number, even integer, positive. Could it be 3? No. Could it be 4? Yes. So what do I now know? All right, so there could be no negative roots. There could be 2 negative roots or 4 negative roots. All right, so the problem now I got to look at basically, trying to figure out what's going on over here. So let's say there's one real positive root. I know that. One positive real root. And I'll list the possibilities now. And there could be 4 complex from this analysis. Again, this is the given over here. There could be 2 complex and 2 real. And these are going to be negative real. Okay, what else could there be? Again, there's always going to be one positive real root. And there could be 4 negative real roots. All right? So what I'm going to claim over here, it's really what the analysis is leading us toward. I want to look at the graph, though, and the reason for that, just to narrow down what I'm seeing. Now, granted, we could do other things to figure out which one of these 3 cases it is. I'm just going to visualize it. How do you visualize it? You would actually look at the actual graph. So I'm going to go to the graph and go back to the document. And over here, let's take a look at it. One step at a time, right? And let's do this very carefully. I definitely see the one real positive root. Now, when you look at this over here, I know it's difficult. I kind of zooming in. I'm seeing 1. I'm seeing 2. I'm seeing 3. All right? Now, granted, they may be hard to detect, and I'm seeing 4. All right? So what do I see of the cases? Let's go back to the cases. So I'm seeing 1 positive and then 4 negative. All right, let's go back over here. And which one is looking at the picture? It's going to be, let's write this down and highlight it for you. Of these 3 cases, it's this one. 1 positive real root and 4 negative real roots. Again, we could have done more analysis without looking at a picture. We could have done some sign analysis, yada, yada, yada. But this is the analysis that we're expected to do at this level. Thank you.